I'm going to get started since there's a lot of content to go over in an hour here, and this is one of those talks where you are going to want time for questions. People will probably trickle in from the keynote, no big deal. So, my schedule tells me that this is a JavaScript track, but this has next to nothing to do with JavaScript. This is about Git, which is the version control system that I hope you guys are using for all of your projects. How many of you have heard of Git but not really used it much? It's about maybe, that's most of the room. Anybody here never heard of it before? You just like a friend dragged you along or something? Nope, okay, that's a good start. And anybody here pretty proficient, pretty comfortable, you can do most of your day-to-day things without Googling, just here to see if there's anything else to learn? Okay, maybe half a dozen people. Cool. So feel free to correct me if I describe anything in a way that doesn't make sense to you. So, hi, I'm Emily Dunham. I'm a former sysadmin at the OSU Open Source Lab, founded a DevOps Bootcamp training program, and generally have spent a lot of time walking newbies through how to do Git things. So these slides will be there for as long as I own that domain. I'll put that link up again on the last slide so that you can see it. I wouldn't recommend trying to follow along with the commands we're going to talk about today. This is much more a focus on exposing you to the ideas behind distributed version control, especially Git and GitHub. And I would like you to know what questions to ask and to be able to ask your questions in a way that will get you the right results when you search for them, so that you can know the names of the parts and be more descriptive than "it's broken." So we're going to talk about the kind of overarching of philosophy of software development that Git assumes that you already know, and then about what it is, ways of learning it. We're going to go through a lot of different commands. I'm sorry if they make your brain feel like it's melting from all of the information overload. Again, the slides will be up there. Don't worry too much if you're only really following about half of it. And we'll go into how GitHub differs from Git. So with that, what's software development? And if you're in a more DevOps type role, bear in mind that infrastructure as code is still more or less software development. You have a lot of the same problems going on. And at the root of it, I'll argue that software development is basically a whole bunch of changing files. Sometimes it's changing a file by working in your editor or your IDE, making some manual change that it would be a real nuisance to have to go repeat that if you lost the changes. Other times, some tool changes files for you based on the ones that you wrote by hand. So you'll run, let's say, your compiler and you'll get your executable. And then the other aspect of these changes is that they happen for a bunch of different reasons. So maybe you have a series of changes that are just an experiment to see whether we can add this feature. Maybe you have another group of changes that represent fixing an existing bug. And it's nice to be able to keep those separate, which we'll talk about as we go on. So when we view software development as just a whole bunch of changes to a set of files, why do we need version control? Because this from PhD Comics is basically what happens when you just have a single file and you need to track the changes. If you can't, I see some people squinting in the back. He's a PhD student, final.doc, takes it to his advisor, gets some feedback. Final revision 2, and he ends up with this ridiculous file name, trying to track all of the different changes that he's made in that particular version. Have you ever done this? Just raise your hand if you've had to have a bunch of copies of your work. Yeah, lots of hands, and a similar group of hands to those who have heard of version control but aren't really using it yet. So he was actually using a form of version control. He was using a technique for tracking the changes that he'd made to enable him to revert a change, to go back to the previous version if he didn't like it. It wasn't a very effective form, and it wasn't really meeting his needs. But in the bigger picture, version control can mean any of a number of things. You can have a formal system like a piece of software that tracks your code history, or you can have a more impromptu system like we saw in the comic. You can have a system that scales really well as you add more and more files to it, or you can have a system that's, that you can't really scale, and so you have to find something else when your project gets bigger. The concepts of centralized versus decentralized are, is there one golden copy that we always assume is the one right answer to what the current version is, and everybody else's changes have to go back into that? Or can we all share changes around between each other without relying on that central repository? So decentralized or distributed version control assumes that we should all be able to share changes with each other, even if one particular repository is unavailable at the moment. So concurrency versus locking, if you've done much software development, you'll be familiar with those words in the context of a program, but you can also have concurrent development where multiple people can work on the same file at the same time, or locking where we have to take turns working on this file. And then I'll talk more about patches versus snapshots as we go into the details. So the reason we need distributed version control is because it's more reliable, both as a security guarantee of, yes, I can look at your changes and be sure that nobody made some malicious change back in the history of that big central repository, as well as if you have that single point of, or if you have a single server go down, no big deal. You can keep on working. This ties into having no single point of failure, which is something that GitHub has moved us away from, which I'll talk about at the end. And if it's sufficiently distributed, you're not dependent on the network. Many older tools, if you want to make a commit of your changes, you have to be connected to the network so you can go talk with the central repository and make sure that change is still acceptable. This is not really that great if you're on a plane or you're in a car and your cell service cuts out and you're generally trying to get your work done in a less connected environment. So with that, there are many popular forms of version control, of distributed version control, but among them, Git is the most widely used in open source. And if you understand the concepts used by Git, it's pretty straightforward to go to a simpler, another system. So again, the buzzwords are decentralized, it's distributed. You have data assurance, which means that you can more or less be sure that if a change set applies to your repository, those are the only changes that were made. And if you put one file in, you need to get the same file out again. That seems really straightforward, but believe it or not all systems guarantee that. You'll also hear, when people talk about Git, the terms porcelain versus plumbing. That's like, think of a kitchen or bathroom. The porcelain is the stuff that the end user actually touches, those commands that the end user interacts with. And the plumbing is all that stuff behind the scenes that makes it work. There are times, and there will be other Git talks at this conference that go more into detail about touching what's in your .git directory, digging around there in the plumbing to do really weird and interesting things. But I'm going to focus on those porcelain commands because my focus here is to make sure you know what questions to ask when you're going out trying to solve your own Git problems, Googling for solutions. It's also a piece of free and open source software, so you know that if you have a copy of the Git source code itself and the original author suddenly stop hosting it for whatever reason, no big deal. You can keep using it with no legal repercussions. If you find a problem in it and you want to fix that problem with Git, you can do that. So let's look at how Git sees your project just before we jump in. You have your working directory, which is just where you've made your changes. And then you have a staging area, which is Git knows, okay, these changes are going to go into the next commit of the repository. And then you have the repository itself, which is the committed changes, and those are permanent. Those that history will almost always be there forever. There are a few cases in which that history can be changed, but while you're new to it, you should just assume that the history will never change. There are ways of undoing things that will leave a record in the history, and I'll explain to you why that's good when we get to them. So let's talk about the exact commands. Don't expect all of this to stick right away. It's going to be a whole lot of specific commands, and memorizing things in an hour is just not a realistic expectation to have. The slides are online. The link will be here again at the end. So first, I've been talking about these repositories. A repository is basically your history of changes to your project. But to set it up, you need to tell Git a few things. You need to tell Git who you are, because later we're going to find out about how every commit knows who made it. And this is important because you can go ask that person, hey, why did you make this change this particular way? You give it your name and you give it your email address. When you start working with other people and pushing your changes to other places, such as GitHub, you're going to need SSH keys. RSA is an older encryption standard, generally more tested, considered more reliable. 2048-bit is an acceptable key size. There's also a type of key called ECDSA, elliptic curve digital signature algorithm, which is newer, makes a smaller key, but isn't supported on all platforms. Like GitHub supports it, but GitLab only does RSA last time I checked. So I'd recommend an RSA key. Through your package manager of choice, you can install Git. If you like graphical interfaces, if you like your tools to show you pretty pictures rather than just print a bunch of output, you might want TK and TCL if you want the graphical user interface that I'll mention as we go on. And often Git will need to know what editor you want for editing your messages or editing merges. So set that editor in your shell settings or in your Git settings, and then you need to get a repository to use Git. So a repository is that database of snapshots that have happened to your code. It contains the entire history of your project. So the repository is stored in a directory within the top level of your project that's the .git directory. You can use ls your .git directory to see what's in it. To get a repository, there's two routes you can take. You can either make a new repository from scratch with the git init command, or you can start with a copy of someone else's repository. To get a copy of the repository, you would git clone, and then the URL where that repository lives. The URL might look like that first thing, git at github.com, and then a path and a .git if you've cloned it via Git, or you can clone it via HTTPS. Or via SSH or HTTPS. We'll talk about that a bit more when we get into GitHub. So to examine that repository that you've just made, generally, most of the time, you can use Git Show if there are a few commits in it. If you've just made a new repository and there's nothing in it, there's nothing for it to show you, so you might get that error. Don't worry, that just means it's empty. We'll put some commits in it as we go along. If you're not in a Git repository, you'll get this subtly different error. This means that you should cd into something that has a .git directory somewhere higher in the file system. And you can also use git log to see summaries of the last several changes. There are a lot of different options that you can pass to git log to see the summaries differently. Man git log is a great place to look for those, but that will just give you the basic default options. So how do we undo making a repository? This will delete all of history. If the repository only existed locally on your machine, you delete the only.git directory, that stuff is gone forever. Now, if you just clone somebody else's repo and then you delete it locally, that's not a hugely big deal. All you're going to lose are any local changes. But in general, it's preferable to figure out how to fix your problem through Git rather than just blowing the repository away and starting again. Although, if you get really lost and really confused and you're just like, help, get me out of here, this is a last resort. You can just nuke the entire thing, reclone, and start again. So now that we have a repository, we can make some changes to our files, and then we can stage those changes. Staging lets us bundle changes to a bunch of different files into the same commit. So a staged change is a change to a file that Git is aware that you're going to want to commit soon. Think of it as it's kind of waiting in the wings, waiting to go out into history. So we can touch a file, just to make a change by making the file exist. And then to stage the change, we use git add. If you git add the file, and then you make some more changes to it, and you don't add it again, then only the changes at the time you ran git add will be added. To examine staged changes, you can use the git status command, and it will give you a really helpful rundown of all the files that are around and where they're at. So it will say the changes that are staged, changes to be committed, you've made this new file, and then if you touched another file and didn't add it, it will be listed as untracked because it's not staged yet, and it very helpfully tells you what commands to use. And if you want to see exactly what would be committed right now, you can use the git commit command with the dry run option. But this Git Show output is generally pretty helpful. So how do you undo having staged some changes? This depends on whether you want to keep the change and just put it into a different commit later on, or whether you want everything to just be gone. I want that file back how it was. That was a terrible mistake. In the first case, then you can remove the cached version. That's like undoing the git add, but not changing the file at all. The file stays how it was. Or if you want to set the file back to the last version that you had in history, let's say you accidentally overwrote it even, then you can use git reset head. Reset says put it back how it was, and head points at the latest commit in the branch. We'll talk more about tags like head in a bit. And then you give it the file name of what you wanted to reset. So now that we can stage some changes, we want to make a snapshot of those changes. A snapshot is basically everything that changed since last time. It tracks all of the files that Git is watching, and it doesn't take up as much space as it would take to keep a copy of all the unchanged files, because it just points back to the last time that, or to the last version of it. So that's just an internal plumbing thing for saving some space. So with that, a commit is a snapshot of the changes. It has some extra metadata on it that you'll find immensely useful later on. So it tracks the author. This is why you told Git who you were, so it knows who to write the commit as. It tracks the date it was committed, including the timestamp. It tracks the committer because sometimes the person who wrote a change and the person who actually applied that change to the tree may not be the same. Let's say you write a fix for something in the Linux kernel and you email it to the kernel developers, and then one of the kernel developers applies it to the tree. They would be the committer, but you would be the author. And it also has the parent commit, which is the one that came immediately before it. Now, since the commit's ID includes a hash of all that stuff in the commit, this makes it impossible to change history and have the same set of commits. To make a commit, you'll just git commit, and that will take everything that's in that staging area and it will wrap it up with that extra metadata. Now, to get the commit message, it's going to pop open your editor and ask you. One option that I like for git commit is if you don't want it to pop open your editor, you just have a line or two of explanation as to what happened. You just git commit -m and then your message, and that will skip the editor entirely. So the reason that we have the wonderful phone booth there is because you can think of version control as a time travel device. It lets you go back to how your repository was in the past. But there's one catch. You can only travel back in time to those points when you remembered at the time to build a little landing pad for your time machine. The commit is basically that time machine landing pad. So now that we've made a commit, how can we examine commits? Come on, there we go. You can use Git Show to show the latest commit in detail. You could use Git Log for the summary of recent commits, like I mentioned earlier. If you want to look at a range of commits, you can use Git revisions to specify the arguments to the log. And you can also use GITK for visually showing all of your commits and giving you a nice graphical interactive interface. So again, Git Show has a whole bunch of different options that you can use. If you want to check a signed commit, you can show the signature and so forth. let's see. So you can also git show and then the hash of a specific commit. If somebody, let's say you ask on IRC and they go, oh, that was fixed in commit, and then this big long string that looks like it came out of a random number generator, you can just git show and then that same string, since it's the commit hash, and it will show you exactly what happened in that change. So how do we undo making a commit? You can git check out the file name from a previous commit that you want to set it back to, and then add the file, commit it to saying you put it back. Or to literally undo a commit, you can revert it. Now, reverting makes a revert commit. This is good because this means that you can undo having undone it. You cannot change history. You can only, as you go on, say, oops, I realized here that that shouldn't have happened, so in the future we're going to pretend like it didn't. But you'll always be able to go back. The general argument against why you might want to revert commit is about letting you hide your own mistakes. There are some tools that I'm going to show you later that will let you rewrite history when it's local to your machine, so that before you share with others, it'll look like your mistakes never happened. But once a mistake has been shared, once it's in the shared history for the project, you would lose that security guarantee of the consistent history back to the very first commit if you were to allow people to just change it. So now that we have some commits, let's look at all this sharing with other people that I've been talking about. So this brings us to remotes. A remote is effectively another repository where you have more or less the same history. You have a bunch of commits in common. They might have some stuff of their own, you might have some stuff of your own, but it's got enough shared history that it's always possible to bring it back together. Remember how back when we were making our repo for the first time by using the git clone command, that just made a copy of the remote repository to your machine? Well, that is now a remote for you. So remotes can have names because you can push changes to them or pull changes from them, and you need to be able to tell Git which remote repository you're talking about. So to add a remote, the git remote man page will have a bunch of very detailed commands, but effectively all you need is git remote add, and then whatever you want to name it, and then the URL where that remote will be. That URL will look just like something you could have cloned it from. So how do you examine the remotes that you have once you've added a few? If you would rather do it in your editor and just fix them by hand by editing the config file directly, you can use the config-e command to edit your local git config. If you want to do it through a command line command, like let's say you're automating in a script for whatever reason, you can use the git remote show command. So remotes will look something like this. Like if I'm working on a project called Monty, then I can have the remote origin, which is, you can tell it's owned by Monty Language and it's called Monty on GitHub. And I can have the remote id for my own copy of that repository. And that's owned by me, and it's a copy. So if I say git push origin and then a branch name, it'll push my changes to origin if I'm allowed to. If I say git push id branch name, it'll push them over there instead. So you can undo adding remotes. You can just edit your config and delete or change that remote, or you can use the git remote commands that you'd find in the man page if you prefer to do it directly through the command line. So now that we have our repository and some other people have more or less the same repository, and we're ready to start sharing changes back and forth, we want to be able to identify particular sets of changes. So to do that, we're going to eventually end up using branches. But to work with branches, it helps to understand tags. So tags are basically just a marker that's tacked onto a commit. It's kind of like a commit of its own in many ways, such as the fact that it can have a hash that includes its commit, which includes all of history back up to that commit. And tags are often used by projects directly if they're tagging it with a version number or a release number, or you could tag with a build status or something. So to add a tag to your repository, just to remind you, hey, here's where things were at that point in time, you can just use git tag, give it a message, and then give it a name. It defaults to being a tag that's just points at the hash of the commit that you're tagging. You can GPG sign tags if you want that extra guarantee of, yeah, I promise that this version works a given way, or what have you. To examine tags, plain old git tag will give you the list of all the tags that are around in the repo right now. You can search through them by a regular expression if there's a lot of tags available. And to set your current repository to a given tag version, all you do is you check out that tag. This is going to look really familiar when we start talking about branches, because branches are effectively just a tag that has some magic done in the background for you to make it easier to use. So how do you undo making a tag? If it's just a local tag, you haven't pushed it anywhere, you can say git tag -d, and then the name of that tag that you're deleting. Now, to remove it from a remote repository, there's this kind of funny syntax. It's just one of those things, one of those handful of quirks that any tool will have. You say git push the remote name, and then colon refs tags and the tag name. You'll see the same syntax when we talk about deleting remote branches. So with that, now that we know that a tag is just a little marker that can point at a given commit, let's talk about branches. Why would you want a branch? Because sometimes you have the project, and then you need to go off here and test whether you can integrate it with that one thing, and then you need to go off there and do a bug fix. And you don't really want all of those changes just thrown in there together, because what if you need to undo, or what if it turns out we can't actually integrate, so we need to undo all those changes? We don't want to have to rewrite history. We don't want to have to wait a long time. So we want to just take a parallel path of development. A branch starts from a commit, and you'll notice that the arrows kind of look like they're pointing backwards. When you've drawn a Git diagram correctly, all the dots refer to commits, and the arrows point at the parent of that commit. So some diagrams will point from parent to child. That's just weird, but some people seem to think it makes more sense. So you can have your master branch there, and then maybe you branch off of master at the beginning for a develop branch, and then maybe you branch off of that develop branch for a couple of feature branches. And then you can just keep going for a while, and then we'll talk about bringing things all back together when we talk about merging. But first we need some branches to merge. To make a branch, you git checkout -b, and then you give it a name. Try to give it a relatively descriptive name. No spaces, please. Spaces in names of things are just generally a bad idea on Unix flavored systems. And having your branch names unique per project makes everything easier. That's shorthand for creating the branch and then checking out the branch. And checking it out just means setting your current repository to the state that that branch points at. Just like checking out a tag will set your current repository to the changes that were pointed out by that tag. So to make the branch on a remote repository, you're then going to have to push your local branch. You push with first the name of the remote you're pushing to, and then the name of the branch that you're pushing. So to examine branches, you can do it from the command line. Git branch will just tell you a list of the available branches with a little star by what branch you're on. Or Git Show, and then the branch name will show you what's up with that particular branch. Same as Git Show would for any old commit. You can also use GITK to show branches. It has a visualization tool. Also, if your project is on GitHub, you can go to some of the graphs that go with the project, and it'll show you who has branches in what repo. So, and it'll give you a kind of a time scale of where commits were, when each branch forked off, and so forth, which can really help with envisioning it. Again, GitHub's arrows point at the child of the commit rather than at the parent of the commit. That might bug you if you're into graphs and math. So how do we undo making a branch? We can, if we're deleting a local branch that all of its changes have been merged, we can git branch -d, and that will do some safety checks to make sure you're not going to lose any changes that were unique to that branch by deleting it. and it will yell at you if you're going to lose changes. If you're just like, nope, that branch was a horrible idea, I wish it had never happened, you can branch delete with a capital D, and that's like sudo delete. Yeah, really, just do it. To delete a remote branch, here's that colon syntax that I was telling you we'd see again. You git push the remote name and then colon the name of the branch. Unlike with tags, you don't have to do the whole refs, tags, anything. It's just the branch name. So now that we've got some branches, we've done some work on the branches, and once you have several branches in your repository, it's always a good idea to use git branch at the start of your development, at the start of each day or something, to make sure that you're on the branch you think you are. It's possible to move commits from one branch to another, but when you're starting out, it's easier to just put them on the branch you wanted to begin with. So we've got some commits, let's say, on our develop branch, and we've got some stuff on our master branch. We want everything to end up in one branch. How do we do that? We merge them. It converges the two branches, and the long story short of how it works is that Git is really magical. Git has some amazing merge algorithms. It has many algorithms for it. It will try them. It will do its very best to just combine all the changes in a way that makes sense. Occasionally it can't, and I'll talk about how to fix it when it can't. So when you're making a merge, the thing to remember is one branch is going to get some new changes onto it. The other branch is not going to have anything happen to it. So the branch that gets the changes is the branch you're merging into, and the branch that nothing happens to is the branch you're merging from. So to make a merge, merging will make a merge commit that will say, hey, yeah, we combine the changes from that branch onto this branch. That's okay. It helps you preserve history, makes it easier to go back in time if you need to. So you pick the branch you want to change. Let's say we want to change the branch called my work. So we check out that branch, so now we're on it. And then you say git merge and the branch that you're merging into it. The thing that follows git merge isn't going to get changed by this operation. And then you can use git status to see what it looks like. It will say what branch you're on, what's going on. And if there was something that Git couldn't figure out how to combine it, you're going to have to deal with a merge conflict. One really good example of this, really simple example, is let's say that we're both, that I and a friend are working on a project, and each of us, the only change we make in our individual branches is to change the name of the project. That's the only thing we do. So in like the configuration file where it says project name, we changed that one line. And then we ask Git to merge those changes. Git has no way of knowing which of us was correct. Heck, we might have to go talk it out, send some emails back and forth to figure out which of those new names was correct. So how can you expect your version control tool to do it? In that case, it will give you what's called a merge conflict and let you fix it by hand. It'll say, sorry, I'm not smart enough. Here, you do it. What a merge conflict does is in the file, it'll put a line of chevrons and the name of the branch that had one version of the content. It'll put the version of the content from that branch. It'll put a line of equal signs. It'll have the content from the other branch, a line of chevrons, and the name of the second branch. So since we were on the branch my work, head was pointing at my work, so that's the branch that the first content was from. Since we were merging master into it, the second content was from master. So how do you know what it should be? You have to actually think about it. You have to look at the project, maybe even run your tests, figure out what it should be. Delete all the chevrons, everything except the correct content. So just manually make the file right, and then save it, git add it, check that you got all of those conflicting files with git status, and then commit those changes. If you want an interactive way of fixing merge conflicts, you can use git merge tool that will kind of walk you through it a bit better. Generally is easier to use when one of the two files was canonically correct. So in this example, maybe the correct thing to put on that line wouldn't be either of those because of how the changes came together. That's why Git needs some human supervision. So now that we've made a merge, we've fixed any conflicts that showed up, how do we examine that merge? You can use git diff and then the commit before the merge. You can get that commit hash out of the git log command. Diff it against the merge commit. That'll show you what happened. Or you can show the merge commit. That'll show you a bit of what happened. You can also, before you merge, see how a given branch differs from the branch you're currently on. So the syntax for that is git log double dot the branch name, or git diff triple dot the branch name. Or if you want a visualization of it and you're going the GUI route, you can use gitk and then triple dot other branch, just like the syntax for git diff. So how do we undo a merge? This will depend on whether you're in the merge right now, you haven't really completed it, in which case you can just git merge abort, like get me out of here, nope, that was a terrible idea. Or if the merge was a while ago and you're like, we should not have actually merged that branch in, that was a terrible idea, you can reset saying to keep a given commit. So now that we can make some commits and reset our changes back to any given commit in history, and then branch, we can have remote so that we can work with other people. We can have branches, and we can push branches to and from to remotes and pull from them. We can merge those branches back together again. Let's talk about changing history. A rebase allows you to reorder a set of commits, or change what was in them, or make a commit like it never happened at all. This can be good if, let's say, you've had some maybe legal or licensing problems and just need to completely remove a part of history. This can be good if you accidentally committed a really large file and having that sitting around in the history is slowing down all of your operations. In general, don't rebase unless you are certain you know what you're doing. If you change shared history, if you change history that applied to other people on a given project, they will be very angry at you and they will demand a very clear explanation of exactly why you did that. So generally don't unless you're willing to deal with that. There are cases when you should. To rebase, you can git rebase -i for interactive rebase, and then you can specify a commit range. Git revisions allows you to specify which commits you're acting on for any of these commands in excruciating detail, and it can be really fun to figure out details to it. Let's say we're just doing the last 4 commits. That'll look like head ~4. This will give you a little editor. You can reorder the commits. I'll show you what the editor looks like. There's another place that you'll see rebase show up that's git pull with a rebase. This means, oops, I should have pulled at the very beginning of today. Let's pretend that I pulled and then just undo all these changes, set them off to the side, pull the changes, and then apply my changes back on. That's a totally cool command to use because you're only changing local history. Nobody knew what the hashes of your commits were supposed to be. Nobody will know that they changed. So let's say we're in an interactive rebase, though. To look at it, it'll show you a list of the commits, and it'll give you that really useful help. Picking a commit says it's going to stay in the tree. R to reword a commit says, I put the wrong message, let's fix it. Squashing commits just combines them down into one, so you'll often want to use that with editing the message to update it. And then you can use a rebase to run a command on every commit. Let's say someone in the project changed their name and it's really important to get their old name out of the history. You can execute a regular expression that will swap the old name for the new name. Actually, in that case, you'd probably, if it was just the author, you'd use amending with editing the author, but you get the idea. It's pretty important to have your Git editor set here again, because it will pop open in whatever you specified as your Git editor. So what if you're partway through a rebase, you're like, I should never have done that, this was a terrible idea, get me out of here. Git rebase makes this tag for you called original head when it starts, because it knows you might want to just go back, undo all of it. Git reset hard to original head will undo a rebase, and rebase abort will get you out of a broken rebase when it's happening. So I have about 15 more minutes till the next talk scheduled to start, because we got 5? Oh, dang.
I'm supposed to give 5 minutes to get out, 5 minutes.
Okay, we have 5 minutes. we can talk about GitHub, or we can take questions on what we've covered so far. Hands for who'd like to hear about GitHub? Maybe half the room. Hands for those who'd like to do Q&A. Got a really pressing question that you don't want to just ask me afterwards. Okay, let's talk about GitHub. 5-minute version of how GitHub differs from Git. It is not exactly Git. It is not distributed. It centralizes things onto the GitHub servers. This takes away some of the benefits of distributed version control that I told you about at the start. GitHub adds access control and user management in a way that Git never intended to. Git doesn't really care who you are, just who you say you are. There's a talk that's linked in the slides, which I'll put the URL up at the end, where Linus Torvalds, the original inventor of Git, yeah, he's also the guy who kind of wrote the Linux kernel. He wrote Git to solve the kernel's problems. Where he goes into more detail about why it's really annoying when people confuse GitHub with Git. So, some gotchas about GitHub. You can have HTTP or SSH clones. I covered that a little bit before. If you get that permission denied public key error, it means you have an SSH clone and you haven't specified what SSH key to use when connecting. That's a little annoying if you forget to add your key to your agent. What's more annoying is that an HTTP clone will prompt you for your GitHub username and password every single time you try to do an operation that interacts with the remote repository. I recommend SSH clones. GitHub has introduced this forking paradigm. It used to be almost taboo to fork a project. It was like a last resort to try to maintain 2 parallel versions of it. But with GitHub's workflow, you can have many repos in parallel because most people don't have permissions to push to a given repository because, again, it's tried to add access control. So a given fork acts kind of like the center of a centralized version control system. The way you get changes from a fork into another fork of the same repo is via a pull request. The old school way of doing this with Git would be to format a patch and then just email that patch to somebody and have them apply it. A pull request, on the other hand, gives you a really pretty graphical interface. It's that green button with that icon on it. It's a formalization of that email that says, hey, would you please merge these changes in? Here's why. Couple of tricks to pull requests. If you have a branch that you've made a pull request from and you add more content to that branch, that content will show up in the pull request. This is very nice if you know to expect it. Very annoying if you've made a pull request from your master branch and then you go on to put some unrelated changes. There's a bunch of user management and access rights. And another problem is that GitHub doesn't demand that you license your code. Just because you've put your code on GitHub doesn't make it open source. It's only open source once you've put an open source license that applies to that code and says, yeah, you're legally allowed to share it. So GitHub also adds a bunch of extra features. It adds a wiki. It adds kind of a pastebin-like thing that can track changes. It's called gists. It adds issue trackers and cool graphs that you can get through to from the right sidebar of the user interface. If you have a README in your repo, it will automatically be displayed when somebody visits the repositories page. And it also supports some continuous integration, which is basically, let's run this set of tests every time you make a change. Fortunately, GitHub has really good docs on how to use all this, since my 5 minutes don't. So a couple of tricks in general when you're working on a larger project and using Git. It's okay to change history locally. It's okay to rebase your commits that you've done today before you push and say, oh yeah, of course I never made those 5 mistakes that I just happened to commit. Those are gone. But it's not okay to try to take something out of shared history. You should have one logical change per commit and have a clear message that describes what happened. And make sure you know your project standards for branching, making tags, and so forth. I think we have like 1 minute left, so I'll use that minute to take any super fast questions. Ben Loveridge has another Git talk that will talk a lot more about how to use GitHub, 9 a.m. tomorrow. And there's my permalink to the slides.